It's the AEMT lecture series. Welcome back. Glad to have you as always. We need to talk about allergic reaction. So let's just dive right into it and take a look at this. It's I won't say it's a complicated process, but it could be made to be complicated. And so let's take a look at it. Why does it happen? Who is our enemy, and how do we defeat the enemy? That's what we have to know when we're dealing with this kind of stuff. When we're talking about the physiology, and we're talking about what's going on. So we know how to defeat it. All right, so let's take a look at this. So over here, just above IgE, right here, you have something called an allergen. All right, and so it sets off an immune response. This is a white blood cell right here. So this is a white blood cell known as a macrophage. This macrophage ingests the allergen and presents the allergen out here as an antigen. This right here is known as a helper T cell. This is a T cell receptor that receives the antigen from the white blood cell, makes a protein out of it, and we send it to the B cell. The B cell then does what it does, sends it to the plasma cells, where plasma cells make something called antibodies. The specific antibody problem we have here is an IgE antibody that's going to be made. And so this IgE antibody is going to be implanted here onto this mast cell. And it rides around. And so this is the reason why we can say that anaphylactic reactions don't normally occur, not always, but don't normally occur on the first exposure. This is all part of that first exposure. Now the antibody, the IgE antibody that's a problem, has been developed. It's riding along here on this mast cell. Let me get my picture out of the way here, sorry. Let me make myself a little smaller here. There we go. And it rides around here on this mast cell, and it's ready. It's ready for the next time an exposure occurs. So when that next time happens, here's your pathogen, or your allergen in this case. It's going to come in contact with this mast cell. This mast cell is going to over-respond, and it's going to develop something known as histamine and leukotrienes and several other things. All right, but we're only going to talk about histamines and leukotrienes right now. All right, so how do these two guys right here affect the blood vessels? All right, so they're going to attack, and we're going to do just like the inflammatory response. We're going to have gaps here in the plasma membrane, because the histamine and leukotrienes have asked them to contract. So plasma now will leak out, causing edema. So with that said, we know that it's overproducing, so we will have a lot of edema. Let's move over here to the bronchioles real quick. So we will have a lot of edema. This edema is going to affect the bronchioles, specifically the mucosa, where the mucous membranes are found as well. So we're going to have an increase in edema, an increase in mucus, And another big thing that's going to happen is these leukotrienes working along with histamine are going to cause smooth muscles like this guy right here, smooth muscles to contract in the bronchioles. They will contract in the bronchioles. They'll dilate in the peripheral. Excuse me. All right. So don't get that confused. Okay. We have dilation here and constriction here. Not only that, let's come over here to the upper airway around the larynx. Okay. And also just below the larynx, these guys are going to do what? They're going to constrict. We're going to have edema. This is known as angioedema. This is where stridor comes from. As these begin to constrict, this air passageway becomes very narrow, and air flowing through this at a velocity is causing that whistling noise you hear. This is extremely serious, and we need to treat this rather quickly, or we'll be dealing with a respiratory arrest. So what can we treat it with? How are we going to treat it? We need a drug that will provide vasoconstriction. We also need something that will act on the bronchioles to cause bronchial dilation. Which drug will that be? Well, we so happen to have epi. Okay. And it has the alpha properties. All right. And so when we're talking about alpha properties, we'll get the vasoconstriction. Okay. That's part of the problem. What about the vasodilation and all of that? Well, the beta properties will provide for that. Beta 1, though, remember, one heart is going to increase the strength of contractions, increase the heart rate, and beta 2. Beta 2 is where you're going to get your bronchial dilations. Okay. What about albuterol atrovent? That's awesome. That's an awesome idea. Albuterol, we know, is a bronchial dilator. Okay. And we have atrovent. Atrovent will provide us with the parasympathetic response that we need to help dry secretions. All right. The dosages. All right. 0.3 to 0.5 for epi. Albuterol is 2.5 milligrams. We'll do a nice 0.5 milligrams of atrovent. All right. It's a short video, it's to the point, but we need to make sure that you have a good understanding of this so that it will help you. All right. Enjoyed the video and look forward to making the next one. Until then, see you next time.